Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and in continuation to our discussion on the types of surfaces in sequence stratigraphy that we are continuing for last few classes. So, we will continue that discussion in this class also, and as part of the surfaces which form under base level fall phase, today we will discuss about another surface, the basal surface of force regression, which is abbreviated as BSFR. So, in today's class we are going to discuss about the basal surface of force regression which forms during base level fall. So, the term basal surface of force regression, it was introduced to define the base of all deposits which will accumulate in the marginal marine environment or maybe in the shallow marine environment during the forced regression of the shoreline. The effect of forced regression is best observed in the shallow marine part. However, we can also observe the effect of forced regression in the deeper marine part as well, and there also, depending on certain conditions, we can identify the basal surface of forced regression. So, this surface BSFR, it is commonly considered as the paleo sea floor at the onset of the base level fall at the shoreline. That means, when the sea level fall started, this surface was the substrate for the next phase of sedimentation during this base level fall. So, this is the first surface which is available. After that, several surfaces may form that we will discuss in this class and also in the next class, but those surfaces are not the basal surface, they are not the first surface. So, basal surface is the first surface. So, this is the paleo sea floor at the onset of base level fall. So, how we define this basal surface of force regression? If I just refer back to this simple base level curve that we have discussed earlier also, and we get the TR curve which goes on like this with an offset. So, if this is the peak of the transgression, this is the peak of the transgression, and from here the regression starts. So, if I look at the base level curve, this is the point from where the base level is started falling, it is the turnover point. So, this point is the onset of base level fall. So, this is the onset, this point. So, the surface corresponding to this particular turnaround of base level which indicates this fall. So, it is in between somewhere within the regressive phase, and already we know that this particular phase is the normal regressive part, and from here we get the forced regressive part. So, this is the onset of the forced regression, this is the onset of base level fall. So, that surface is identified as BSFR. So, the underlying litho unit, the package of strata is definitely HST, the high stand systems tract, and the overlying strata is commonly the falling stage systems tract. The overlying strata is the falling stage systems tract. So, already we know HST is a normal regressive package. So, during HST we will expect formation of this kind of coarsening upward succession where the grain size is increasing towards top, and then we get this particular surface which we call as the BSFR surface. So, this is the HST package, and on that the forced regressive package has started. So, again we get another coarsening upward succession. Already in the previous classes we have discussed about unconformity. So, unconformity can get superimposed with BSFR when instead of this deposition we get erosion, and that is a common case in the marginal marine part or into the continental part, particularly within the fluvial part, when during this base level fall we get erosion or fluvial incision or the bypass. So, in such cases instead of BSFR we will get unconformity, subaerial unconformity that we have already discussed in our previous class. So, for the preservation of BSFR, what we require this deposition, which we commonly term as the falling stage systems tract, which is a coarsening upward succession. So, BSFR should be preserved at the bottom of the next falling stage systems tract, and very commonly we get this falling stage systems tract to be developed within the marine system. That is why the BSFR is always preserved at the bottom of the marine succession, which is formed during the falling stage or during the forced regression. In seismic stratigraphic terms, the BSFR, this basal surface of forced regression, this is the oldest clinoform. This is the oldest clinoform which is associated with offlap. As already we know, we have discussed on our class in the stratal termination pattern. So, there we have discussed about offlap, which forms during the forced regressive phase, where successive exposed portions they get eroded and we get a new erosional surface formed, and successive clinoforms they overlap each other. So, in such cases, the oldest clinoform from where this offlap is starting, which is associated with the forced regression. So, during this offlap, the start of the offlap, the first clinoform is the BSFR surface. Or in other words, if I look into the underlying normal regressive high stand package, the HST package, then this is the youngest clinoform within that normal regressive deposit, from where the offlapping is starting. So, this is the youngest clinoform within the underlying HST package, which is normally a downlapping package, or it is the oldest clinoform within the forced regressive package, within the offlapping package that is forming as part of the falling stage systems tract. So, in seismic stratigraphic terms, in seismic profiles, we can identify this surface as a combination or any one of these two aspects. So, either at the base of the offlapping package or at the top of the downlapping HST package, from where the offlapping is starting or forced regression is starting. So, for the preservation of basal surface of forced regression, what we require is there should be some amount of sedimentation which will overcome or which will overpass the erosion caused during the forced regression. Then only this surface is preserved. So, how this basal surface of forced regression will form, how it look like. So, we can draw a simple diagram to understand how we can identify the basal surface of forced regression or how it looks like. Say if I draw a marginal marine section, because basal surface of forced regression will form in the marginal marine part. So, in this marginal marine part, this is the end of HST. So, we are getting this particular surface at the end of the HST, and this is the sea level or the base level at time T1. So, this is base level 1 at time T1. Now, this base level is falling and it is reaching to base level 2 at time T2. So, during that time base level is coming over here at this level. So, in response to this much of fall in the base level, what will happen? We will get some wave erosions, wave reworking or shallow marine reworking processes. So, what we get over here, due to this much of depth of the base level, we will get a new wave equilibrium profile is formed like this. So, this wave equilibrium profile, that means the wave erosion is going on along this particular line. So, this part of the substrate is eroded and erosion is going on over here. So, what is happening now? This part, this particular zone, this is the area where sediments are accumulating. They are not reworked or eroded by the wave processes or shallow marine processes. So, this part of the shallow marine area, this part of the substrate is giving us a new surface which is actually the top surface of the last HST which is getting preserved, and on that we are getting deposition of sediments in a conformable way. So, there is no unconformity in between these two packages, HST package and this new package. So, this new package of sediment is forming during the forced regressive phase. So, definitely this is part of the falling stage system tract, and this surface which is representing the youngest clinoform at the end of the HST, underlying HST, or the oldest clinoform at the start of the FSST. This is the substrate, this is the surface which was available at the start of the forced regression. So, this surface will be called as the BSFR surface. So, this is available up to this point only, because after this point it is getting eroded or reworked by the wave equilibrium or the Salomarine reworking processes. So, we get the preservation of BSFR only in a limited extent and particularly within the Salomarine part, because if I continue into the fluvial part, there it is not continuing, because there the fluvial incision or bypass is going on, which will lead to the formation of unconformity surface. So, there the preservation of BSFR is not possible. We cannot expect preservation of BSFR in that particular area. Similarly, we cannot get this BSFR into the deeper part, particularly within the wave equilibrium region, within the wave base where wave reworking is going on. If I go beyond the wave base, somewhere below the wave base, then the wave equilibrium will not affect the substrate, and there again we can get the preservation of BSFR. For example, in the self environment, where if there is no storm, then it is definitely beyond the wave base, below the wave base, and their normal wave equilibrium is not affecting them until and unless the base level is falling significantly. So, in such case only we can get reworking of the self sediments and the BSFR will not be preserved. Otherwise, in the self environment we can expect preservation of BSFR. We will discuss about this later on. So, when this kind of surfaces are preserved from subsequent erosion, or in that part of the basin where this kind of surfaces are preserved from subsequent erosion, the BSFR occurs within a fully marine succession. As you have seen, the underlying one is the high stand normal regressive strata, and the overlying one is the forced regressive strata, which commonly is indicated by a falling stage system tract. And both of them are definitely marine succession. So, if I think of this part of the basin, the HST part, so maybe this is the distal shore face or simple distal shore. On that, this portion is the proximal shore maybe. But entirely it is the shore environment, entirely it is within the marine system. So, a distal shore, maybe the outer shore face is overlain by inner shore face, like this. So, we can get this kind of depositions, this kind of packages separated by this surface called as BSFR surface. So, on the self part, when you look into the little bit deeper part of the basin, the BSFR is commonly downleft by the younger forced regressive prograding clinoforms. So, in that case commonly we get the self package at the bottom in the HST part, and that is overlain by commonly the shore sediments, shore face sediments coming over there during the falling stage system tract. So, in those cases identifying the BSFR is bit easier, whereas if I look into the marginal marine part where shore faces is overlain by another shore faces, it becomes bit difficult sometimes to identify BSFR because it is a conformable succession. So, when we get a very high magnitude fall in the base level, in such cases the subaerial exposure of the entire Salomarine seafloor may occur, and the self area may get even exposed to or may get affected by the wave reworking processes. In such cases, when such high magnitude fall in the base level is going on, in such cases the chances of preservation of the force regressive deposits is very low, and definitely the chances of preservation of the basalt surface of force regression is also very low. So, if I look at this particular diagram, say instead of this much of fall, if the base level fall comes down to this, up to this much of level. So, say this is base level fall at time t4, BL4, and base level is coming down to this level. So, in such cases, the wave reworking is now going on over here. So, due to this much of wave reworking, the new wave profile, equilibrium profile will be something like this, and this part is entirely exposed and it is prone to subaerial erosions or bypass. So, we will get subaerial unconformity form over here, which may lead to deletion of removal of this basalt surface of force regression, and also the removal of the force regressive package that was deposited during the early phase, during BL1 or BL2 phase. So, when this base level fall is significantly high, its magnitude is very high, in those cases the chances of preservation of the basalt surface of force regression and the associated falling stage systems tract is very low. When the magnitude of fall is significantly low, the magnitude of fall of the base level, the preservation potential of the basalt surface of force regression within Salomerin succession increases significantly. So, what we require, there should be low amount of fall in the marginal marine part, which can result in preservation of the BSFR. Now, this nature of scouring, how much scouring will be there, how much scouring by this wave reworking process will go on, and how much aggradation of sediments, accumulation of sediments will go on, these two are commonly controlled by the Salomerin seafloor condition that is occurring during the force regressive phase, and that is commonly controlled by what is the energy condition of the Salomerin system in terms of wave energy system, and what are the nature of sedimentation, how much is the rate of sedimentation, and how these sediments are accumulating, forming prograding clinoforms. So, if the rate of sedimentation is low, clinoforms may be almost parallel to the substrate, and in such cases the wave reworking may have more effect in reworking the substrate as well as the sediments. If sedimentation goes on at a much higher rate, in such cases they may accumulate more quickly, forming more steeper clinoforms, more prograding clinoforms, and those prograding clinoforms may reduce the effect of wave reworking, leading to preservation of the original basalt surface. So, we can take one example again over here. So, we can differentiate between two different cases. One case where we take a Salomerin environment, wave dominated, where the seafloor gradient is very gentle, very small, maybe around 1 degree, less than 1 degree, which is a very common thing, and it is in complete balance with the wave energy which is dominating over there. It is balancing the sediment supply over there. So, that can be one case. And the second case where we are getting a river dominated condition, again a marginal marine system, but a river dominated condition where the river system is supplying huge amount of sediments into the system, and as a result of that the clinoforms which are produced here, its angle of repose is quite steeper. So, in such cases the wave equilibrium profile becomes relatively gentler with respect to the angle of repose of the clinoforms. So, what will be the result of that? Say for example, if I take the first example, so the surface is like this, the substrate is like this is the base level, and this base level is falling to this one, and as a result this is the new base level now. So, with respect to this base level, we have a wave equilibrium, wave reworking, and this wave reworking, say for the first one, the wave equilibrium was the same one, this surface. So, substrate and the wave equilibrium were at the same level. Now, as the base level is falling to this particular level, due to this new wave equilibrium will be maybe something like this under this new water level, new base level condition. So, what is happening now? This part is exposed to subaerial erosion. So, subaerial unconformity will form, whereas this part, this entire part is now prone to, is now affected by this wave reworking process. So, in such cases the original substrate, this is the original substrate. So, it is completely removed from the system, it is not preserved at all. We are getting a new surface formed by this balance between the original inclination of the substrate and the wave equilibrium at that particular base level position. So, in these cases, in this kind of conditions, the chances of preservation of the force regressive package as FSST and corresponding BSFR at the base of that package, its preservation potential is very low. On the other hand, if I consider another condition, for example, say you have a system like this, where lot of sediments are coming in and they are producing this kind of prograding clinoforms in a very steeper way. By the time these are coming up, base level was here, and from this base level is coming down to this level, maybe somewhere here base level is coming down to this level. So, for this particular base level definitely will have a wave reworking, and this wave reworking will be something like this, the wave profile. The wave equilibrium profile is going on something like this. So, definitely the erosion is now confined over here in this zone only and above this particular surface, not below this. So, the clinoforms which are produced here, which are coming over here, they are getting preserved, and as a result of that, this particular surface, which is the original substrate, is also getting preserved. So, in this case what we are getting is the preservation of the FSST package and preservation of the BSFR package. So, whether BSFR will be preserved or not, it depends on these factors. What is the base level position, what is the inclination of the substrate sea floor at that particular point of time, and what is the relation of wave equilibrium with respect to sediment supply into the system. All these factors together will control what will be the nature of accumulation of sediments, and that will control whether the original substrate is preserved, maybe entirely, maybe partly, and depending on that whether we get the BSFR preserved within a sedimentary succession or not. So, in wave dominated settings, for example, in subtidal environments, in microtidal settings, or maybe in front of the open coastlines or in wave dominated deltas, these areas are quite prone to such wave scouring during force regression, because in such areas the sea floor, it tries to maintain a graded profile in accordance to the changing wave energy condition. As the base level is falling, with respect to that the wave energy is also getting adjusted, and accordingly the sea floor will try to maintain a graded profile, maintaining that equilibrium, maintaining a balance with that. So, in such settings the preservation potential of the BSFR as a conformable paleo sea floor is relatively low. So, the onset of fall paleo sea floor, the paleo sea floor at the onset of fall of the base level may be preserved adjacent to the shoreline positions where the base of the earliest prograding force regressive lobe is preserved. If it is reworked by the subsequent phases of erosions during the subsequent phase of fall, what we get is a new erosional surface, and that erosional surface is termed as the regressive surface of marine erosion, another very important surface in sequence stratigraphy, in sequence stratigraphic packages. We will discuss about that RSME surface in our next class. So, that RSME surface will form in the offshore board direction related to a lever point, which indicates the point of balance between sedimentation and erosion. So, what is this concept of lever point? So, we can take again one example. So, what will be the location of this lever point? It depends on the balance between the sediment supply and the wave energy. How much is the wave energy, how much sediment is removed, how much sediment is allowed to accumulate. And as we move seaward, as the sediment supply increases relative to wave energy, and it can be the reverse, as we move towards the landward side, the sediment supply is less with respect to the increasing wave energy condition. So, in wave dominated shallow marine successions, the conformable basalt surface of forced regression may be preserved in two distinct areas, separated by a zone of wave scouring, which is controlled by this lever point, which forms at the onset of fall of the paleo seafloor. So, number 1 is the base of early fall gradationally based surface deposits. So, at the base of the gradationally based surface deposits, which are formed at the early phase of the base level fall, and at the base of the force regressive self deposits. In these two areas, we can get preservation of the basalt surface of force regression depending on what is the relation of wave energy and the sediment supply in that particular system during these successive phases of fall. That position of the lever point will control that whether really we will get preservation of the BSFR in these two zones only. If allowed, then only we can get preservation in these two zones, one at the near coastal area, near shore area, where we get shore face deposits, and those shore face deposits are gradationally overlying the earlier HST deposits. So, shore face deposit may be replaced by foreshore deposits as well, depending on the condition. And the second one is the self area, where regressive self deposits are produced during the base level fall. Let us try to understand this with a diagram. So, this is a section of the marine condition, the shallow marine part, starting from the shore area over here and the self area somewhere here. So, this is the base level at the onset of force regression. So, this is level 1. So, from this level 1, the base level is coming down to level 2 through successive phases. So, due to this phase of base level fall, as it is coming down over here, the wave equilibrium profile, which is going on like this. So, it will be something like this, its position will be something like this. So, if this is the amount of sediments accumulating, the wave equilibrium profile may be something like this. So, that means when we have the wave equilibrium going on with respect to this level 2 of base level, the wave equilibrium is going on in such a profile, that means this area is prone for erosion. Any sediments coming in over here will be removed by wave reworking processes. So, what we are getting over here, what are the areas where we can get deposition? Number 1 position is this zone, as I have stippled over here, this particular area, where we are getting some deposition, as well as we get deposition over here in this part, where we get the deposition of maybe the self deposit again. So, in this kind of condition, what we are getting? Preservation of the basalt surface of force regression in this area, because this is the original surface preserved, and the preservation of the basalt surface of force regression over here in the self area, because this is again the original surface. Here the underlying package is an HST package, here the underlying package is an HST package. In this part we do not know, because it will depend on how much is the erosion going on. So, this particular point, which is the cross cut of the substrate or the sea floor with wave equilibrium profile, that is called as the lever point. So, this lever point, its position will control that what will be the amount of erosion with respect to the amount of sedimentation, and the position of this lever point will control that whether we will get the preservation of BSFR or not. If this lever point is allowing preservation of the FSST package, in that case we get preservation of BSFR over here and BSFR in this zone. So, BSFR very rarely we can get in a continuous fashion. We can get BSFR in this kind of patches, one in the self area, one in the marginal marine part where original shore face deposit may be overlain by foreshore deposits. So, when BSFR is preserved either within the shore face area or within the self successions, it poses the same recognition problem as we discussed in case of correlative conformity. Because in case of correlative conformity, what we have seen that it is a continuous conformable succession of coarsening upward strata. In case of BSFR also it is the same problem, because here also at the bottom we are getting HST, which is a coarsening upward package, and then we are getting a conformable surface, over that we are getting FSST, which is again a coarsening upward package. So, proper recognition, identification of BSFR, even if it is preserved, is problematic. Even we cannot identify this conformable basalt surface of forced regression using ichnological criteria, because ichnologically we rarely get any variation with respect to substrate controlled ichnofacies across the BSFR, because you can see from this earlier diagram that the underlying package is the shore face one, the overlying is also a shore face one. So, there is not much variation with respect to substrate condition, not much variation in terms of energy condition. If I look into the self area, the HST self is overlain by FSST self, both are self deposits. So, again very rarely we get any variation with respect to substrate condition, with respect to energy condition, and that results in very low contrast in terms of ichnological criteria, in terms of ichnofacies assemblage, or in terms of ichnofabric across that particular surface. So, using ichnological data, it is again quite difficult to identify BSFR. When the BSFR can be correlated with RSME surface, that is the regressive surface of marine erosion, which can lead to some sort of gap in the sedimentation, in those cases we can get a firm ground formed along the RSME, and we can get glossy fungites ichnofacies associated with that. But in most of the cases that glossy fungites actually is associated with formation of RSME, not the BSFR surface. So, it remains difficult. When you look into the deep water environment, the basal surface of forced regression is commonly taken at the base of the prograding submarine fan complexes. So, at the base of the prograding submarine fan complex, commonly they scour the earliest gravity flow deposits, and they commonly form through these scouring processes, which actually form during this forced regressive phase due to significant fall in the base level in the deep marine part. So, in such cases the BSFR separates the pelagic sediments which have formed during the HST like a condensed section from the overlying gravity flow deposits which are forming during the early phase of forced regression. So, if I want to conclude now, basal surface of forced regression, this is again a very important surface associated with the falling phase of the base level. So, this surface indicates the start of fall of the base level. So, it is often found at the base of the falling stage systems tract, at the base of the forced regressive package, at the base of the offlapping package within a succession. But this is a conformable strata, this is a conformable surface, and it becomes very difficult to identify this surface in a rock succession, because the underlying and the overlying packages across this surface are coarsening upward succession formed during regressions, and there is very rare contrast in terms of facies association, in terms of ichnological associations. but within a succession, if we can identify a basal surface of force regression, it gives us a very important clue, very important information about the start of the force regression during that particular phase of base level cycle. So, from that point of view, BSFR is a very important surface. It can be correlated with unconformity in the marginal marine part, in the continental part, and it can often be used as a boundary, as a sequence boundary, as a system strut boundary. So, overall BSFR is a very important surface in sequence stratigraphy. So, these are some of the references that you can follow for further reading. So, thank you everyone.